Okay guys, so in this example, we're going to go ahead and find the area of this nonagon. It says a regular nonagon is inscribed in a circle with a radius of 4 units. So here I have the two radii here that are formed, and it has 4 units. Now I'm going to try to, in order for me to find the area, I have two options. I can find the apothem and the perimeter, or I know the number of sides, and I'd be multiplying it by the side length. So I think at this point I'm going to go ahead and work with that one. So I'm going to go ahead and just draw this picture, this triangle, but a little bit larger, so I can see what I'm working with. So let's say this is a perfect triangle, which it is not, but I'm gonna, let's see, grab another marker. So the side lengths here are 4. Now I know that now I need to figure out what this angle here is so that I can try and figure out what anything else will be. So I'm gonna go ahead and do 360 divided by 9 equals 40. So that means that this entire angle here is 40 degrees, but I'm gonna go ahead and cut it in half so that I can go ahead and find, I know this side and I know the angle. Now I just need to find this side here. So if I bisected here, this triangle in half, then I know this angle is going to be 20 degrees, and this is x. So I'm going to go ahead and do use 20, so opposite over hypotenuse, that's sine. So I'm using my trig ratios here, so sine of 20 equals, not 4, opposite is x over 4. Now I'm going to multiply both sides by 4, and I get x equals 4 sine of 20. And then now I'm going to go ahead and multiply this by 2 because I want to figure out the whole thing. So right now if I find x, I'm only going to solve for this length here, but I want the whole thing. That way it gives me technically it's called my s, my side length. So if I multiply this by 2, then this becomes an 8. When I plug this entire thing, I'm going to just actually switch this to an s now. So when I plug this into my calculator, I get, you know what, I'm actually going to just leave it as is for now, just so you can see how I'm going to be plugging all of this into my calculator. And now I'm going to be using the area, so area equals 1/2 the, let's see, 1/2 a for the apothem times the n times s. And so I'm gonna be solving for the apothem. Actually, I need to find what this here is. So I would be doing sine, let's see, not sine. I'm gonna separate this. So I know my n is 9. And then my side length is 8 times sine 20. Right over here. Now I need to find this side here, my apothem. So I'm gonna be using the degree 20, opposite. Actually, if I do adjacent over hypotenuse, that is cosine. So cosine 20 equals, I'm just gonna a apothem over 4, right? That's from my trig stuff that we did a while back. I multiply both sides by 4, and then I'm left with a equals 4 times cosine of 20. And I'm just going to go ahead and plug this in here so that I can go ahead and plug everything all at once, all divided by 20. When I do that, I'm going to go ahead and round it, and I plug that in, make sure that I'm in degrees, and I'm going to be rounding it to my nearest tenths, and it's going to be about 46.3 square units. Okay. So actually, yeah, when they don't give us any units or measurements like that here, then it's just square units. So, units squared. Okay, so this was the very first one. Again, there are different ways to solve it. You could have done the other formula, the 1/2 apothem times the perimeter, but I think that one you would need to do a little bit more work in terms of trying to find the perimeter. So it really depends. It's all up to you and see what you feel comfortable with and what you want to do. And then that way you can go ahead and use those choices that you have to solve for your problems. Okay, so this was example 2. And so we're going to go ahead and try another example in the next video.